Hello students, welcome back. Now we are going to discuss about regarding light emitting diode. Okay, that is LED, right? Light emitting diode. Now we'll see the introduction about this light emitting diode, right? So actually, in case of optical fiber communication applications, we use the light sources. Okay, we use the light sources which are heterojunction semiconductor laser diode and light emitting diode. Okay, so these two diodes are used for optical fiber applications. Fine. So these two are the light sources. Okay, these two are used as light sources for optical fiber applications. Now we see about first one, light emitting diode. Okay, light emitting diode. So here the laser diode is also called as injection laser diode. Okay, here we have written laser diode, na, right? That laser diode is also called as injection laser diode. Okay, now coming to this light emitting diode, right? So these LEDs, okay, these light emitting diodes are used in multi-mode fibers. Okay, the LEDs are used in multi-mode fibers, since normally it is only into a multi-mode fiber that the light emitting diode produce the incoherent optical power. Okay, it produce the incoherent optical power which is coupled into the optical fiber. Okay, which is coupled into the optical fiber, and that is useful. Okay, that is also useful. Which one? Light emitting diode. For the optical fiber communication systems, okay, for the optical fiber communication systems, the bit rates, okay, the bit rates, that is bits per second, that should be less than approximately 100 to 200 mbps, 100 to 200 mbps, together with multi-mode fibers coupled optical power in the tens of microwatts. Semiconductor LEDs are the best light sources here. Okay, so the bit rate that should be less than 100 to 200 mbps together with multi-mode fibers coupled optical power in the tens of microwatts. The semiconductor LEDs are the best light sources here. Okay, in case of optical fiber, the semiconductor LEDs are the best light sources, and these LEDs are of incoherent optical power. They can produce the incoherent optical power. So the LEDs require the less complex circuitry. Okay, LEDs require less complex circuitry than the laser diodes, and these LEDs are having less expensive. Okay, that can be fabricated by less expensive with a higher quality, right? So they can be fabricated with less expensive, and the LEDs are used for high speed local area applications. Okay, LEDs are used for high speed local area applications. Next, the LEDs are a typically PN junction diode device. Okay, the LEDs are having PN junction device used under a forward bias. The LEDs are which are having PN junction, right, and that can be used as forward bias. So the conduction band of this semiconductor is populated by electrons. Okay, in case of the PN junction diode, the semiconductor is populated by the electrons which are injected into it by the forward bias. Okay, by the forward bias. Next, it will emit the light here. Okay, it will emit the light. Okay, when the electrons are recombining with holes in the valence band to emit a photon. So to emit the photon, the electrons are going to recombine with the holes in the valence band. Okay, to emit a photon, the electrons are going to recombine with the holes in the valence band. So this is the basic operating mechanism through which the light is emitted from an LED. Okay, so actually this LED is having PN junction. Okay, so if you see in this figure, right, so here it is having two regions here, P and N, right? So this one is of N region and this one is of P region here, and the middle one is having depletion region. Okay, so here the PN region which is connected to in forward bias. Okay, because here the N is connected to the negative terminal of battery, and the P region is connected to the positive terminal of the battery. So we can say that this PN diode is in forward bias here. Now whenever we connect this PN region to forward bias, okay, then the holes which are connected to the positive, so that will be repelled from this positive terminal. Okay, here also the electrons are repelled from this negative terminal, means the electrons will jump to P region and the holes will jump to N region here, means that will recombine with each other. So at that time the depletion region length will be decreased here. Okay, the width of this depletion region will be decreased. Okay, so while the electrons are recombining with the holes, it will emit a light here. It will emit the photon. Okay, that will be visible as light. Okay, hence we can call it as light emitting diode. Okay, hence we can call it as light emitting diode. While the electrons are going to recombine with the holes in valence band, it will emit the light. Okay, so hence it is called as the light emitting diode here. Okay, so always in case of LED, the PN region that is connected in forward bias. Okay, now we'll see in conducting bands. So this figure shows lowering the barrier potential with a forward bias allows majority carriers to diffuse across the junction. Okay, so here the electrons and holes are recombining with each other. So at that time the light, means the photon will be emitted from it. Okay, now we'll see that figure. Okay, now if you see this figure, so this one is of conduction band and this one is of valence band. Okay, the gap between these two bands are direct band gap energy. So okay, that is the E direct. Okay, that is the E direct here. So whenever it is connected in forward bias, the electrons are going to combine with these holes here. The electrons are going to combine with these holes, that is electrons transition. Okay, so whenever the electron is going to recombine with the hole, it will emit a photon. Okay, it will emit a photon that is equal to H in U. Okay, that is equal to E direct here, that is direct band gap energy. So E equal to H in U. So while the electrons are going to recombine with these holes, it will emit the light in terms of photon here. Hence this diode is called as light emitting diode. Okay, so this figure shows the electron recombination and photon emission for a direct band gap material. So mostly for these light sources we use direct band gap materials. Okay, mostly for these light sources we use direct band gap materials. So what is the direct band gap material, what is indirect band gap material, that we will see in next video. Okay, so this is regarding LED here. Okay, light emitting diode, right? So it is one of the light source which is used for the optical fiber communication application, right? So these are mostly used in multimode fibers. Okay, why? Because it can produce the incoherent optical power. Okay, it can produce the incoherent optical power, that's why it is used in multimode fibers. Fine. Okay, so that is regarding light emitting diode introduction. Okay, thank you all. Thank you.